Imagine your brain as a bustling city, with messages constantly flowing through its intricate network of streets and highways. Each thought, emotion, and action is like a vehicle navigating this complex urban landscape, directed by traffic signals and guided by road signs. These messages, carried by chemical messengers called neurotransmitters, dictate everything from our thoughts and emotions to our physical actions. Neurotransmitters are the brain's way of communicating, ensuring that every part of this city operates smoothly and efficiently. In post-traumatic stress disorder, a debilitating condition that can arise after experiencing or witnessing a traumatic event, this intricate communication system goes awry. The trauma disrupts the normal flow of traffic, leading to confusion and distress. The city's traffic lights malfunction, causing gridlock and chaos. Signals that once directed smooth flow now send mixed messages, leading to a breakdown in communication. Fearful memories resurface unbidden, like phantom sirens wailing in the night. These memories can be triggered by seemingly innocuous events, causing the individual to relive the trauma repeatedly. Sleep becomes elusive, and the world feels perpetually unsafe. The brain's inability to process these traumatic memories properly leads to a constant state of hypervigilance and anxiety. To understand PTSD, we must delve into this bustling cityscape of the brain and decipher the language of its malfunctioning messengers. By studying the brain's communication pathways, we can identify where the breakdowns occur and how they affect overall function. By understanding how neurotransmitters operate in both healthy and PTSD-affected brains, we can begin to develop targeted treatments that restore balance and alleviate suffering. This involves not only pharmacological interventions but also therapeutic approaches that help rewire the brain's communication network. This journey into the neurochemical underpinnings of PTSD is not just about understanding a disorder, it's about illuminating the very essence of how our brains process fear, memory, and resilience. By mapping out the brain's response to trauma, we can better understand the mechanisms of recovery and resilience. It's about offering hope for healing and restoring harmony to the city lights within. Through continued research and compassionate care, we can help those affected by PTSD find their way back to a place of peace and stability, where their inner city can once again thrive and flourish. Deep within the brain, nestled like a vigilant guard, lies the amygdala, the control center for our fear response. This small, almond-shaped cluster of nuclei is responsible for detecting threats and initiating our body's rapid response to danger. It's a crucial part of our survival mechanism, honed over millennia of evolution. When danger lurks, the amygdala sounds the alarm, triggering a cascade of physiological changes designed to keep us safe. This response is almost instantaneous, preparing us to either fight the threat or flee from it. Our heart rate spikes, our muscles tense, and our senses become hyper-alert, all thanks to the amygdala's swift action. Noradrenaline, a neurotransmitter often likened to adrenaline, plays a crucial role in this fight-or-flight response. It acts as a chemical messenger, transmitting signals between nerve cells and amplifying the body's alertness and readiness to respond to danger. This neurotransmitter is essential for mobilizing energy and resources in times of stress. Imagine noradrenaline as the blaring siren that jolts us into action, increasing heart rate, sharpening senses, and flooding the body with energy. This surge of noradrenaline ensures that we are physically and mentally prepared to handle whatever threat we face, whether it's a predator in the wild or a modern-day emergency. In PTSD, however, this alarm system becomes hypersensitive, like a smoke detector triggered by a speck of dust. The amygdala's response is exaggerated, and noradrenaline levels can skyrocket even in the absence of real danger. This hypersensitivity can make everyday situations feel overwhelmingly threatening. Even seemingly harmless stimuli can send noradrenaline levels soaring, leading to panic attacks, hypervigilance, and intrusive memories. For individuals with PTSD, the world can become a minefield of triggers, each one capable of setting off a debilitating fear response. This constant state of alertness can be exhausting and debilitating. This noradrenaline surge also disrupts the delicate balance of cortisol, a stress hormone that typically helps us recover after a stressful event. Cortisol is meant to bring the body back to a state of equilibrium, but in PTSD, its levels can become chronically elevated. This imbalance can have far-reaching effects on both physical and mental health. In PTSD, cortisol levels can become chronically elevated, leading to a host of physical and mental health problems, including sleep disturbances, difficulty concentrating, and an increased risk of depression. The body's inability to properly regulate stress hormones can create a vicious cycle, where stress begets more stress, and recovery becomes increasingly difficult. Understanding noradrenaline's role in PTSD is crucial for developing treatments that can dampen this overactive alarm system and restore balance to the stress response. Researchers are exploring various approaches, from medications that target neurotransmitter levels to therapies that help retrain the brain's response to stress. By gaining a deeper understanding of these mechanisms, we can hope to offer better support and relief to those affected by PTSD. Dopamine, often dubbed the feel-good neurotransmitter, plays a complex and often paradoxical role in PTSD. This chemical messenger is not just about pleasure and reward, it is deeply involved in how we process fear and trauma. When we experience something pleasurable, dopamine is released, reinforcing the behavior that led to the reward. However, its role in fear conditioning is equally significant and far more complex. While typically associated with pleasure and reward, dopamine also plays a crucial role in fear conditioning, the process by which our brains learn to associate a particular stimulus with danger. This dual role of dopamine means that it can both motivate us towards positive experiences and anchor us to traumatic memories, making it a double-edged sword in the context of PTSD. Imagine a soldier returning from combat who flinches at the sound of a car backfiring. This reaction is not just a simple startle response. It is a deeply ingrained fear response that has been encoded in the brain. The sound of the car backfiring is reminiscent of gunfire, a sound that the soldier's brain has learned to associate with immediate danger and life-threatening situations. This seemingly irrational fear response stems from dopamine's involvement in encoding the traumatic memory. During the traumatic event, the brain is flooded with dopamine, which helps to cement the memory of the event in the brain. This is a survival mechanism, ensuring that the individual remembers the danger and avoids it in the future. The soldier's brain, flooded with dopamine during the initial trauma, has learned to associate the sound of gunfire with danger, and this association persists long after the danger has passed. This is why the sound of a car backfiring can trigger a flashback, causing the soldier to relive the traumatic event as if it were happening all over again. This fear conditioning can extend beyond specific triggers to impact broader aspects of a person's life. The constant anticipation of encountering a trigger can lead to chronic anxiety and hypervigilance, making it difficult for individuals to relax or feel safe in their environment. Over time, this can result in avoidance behaviors, where the person starts to avoid places, people, or activities that they associate with potential triggers. The anticipation of encountering a trigger can lead to avoidance behaviors, social isolation, and a diminished capacity to experience pleasure. This can severely impact a person's quality of life, making it difficult for them to engage in social activities, maintain relationships, or pursue their interests and goals. The fear of encountering a trigger can become so overwhelming that it overshadows all other aspects of life. In essence, dopamine's role in PTSD highlights the intricate interplay between fear, reward, and motivation, and underscores the need for treatments that can help rewire these maladaptive associations. Effective treatment approaches such as cognitive behavioral therapy and exposure therapy aim to help individuals reprocess their traumatic memories and reduce the power of these fear-based associations. By understanding the role of dopamine in PTSD, we can develop more targeted interventions that address both the fear and reward pathways in the brain, ultimately helping individuals to reclaim their lives from the grip of trauma. In the intricate symphony of brain activity, GABA acts as the conductor's baton, quieting the orchestra and maintaining a sense of calm and balance. This inhibitory neurotransmitter acts like a braking system, preventing neurons from firing excessively and keeping anxiety in check. However, in the aftermath of trauma, GABA's calming influence can be overwhelmed. Imagine a car careening down a hill with faulty brakes. Similarly, in PTSD, the brain's ability to regulate anxiety becomes impaired, leading to a state of constant hyperarousal and tension. This GABA deficiency contributes to a range of debilitating symptoms, including insomnia, irritability, and an exaggerated startle response. Restoring GABA's inhibitory tone is crucial for alleviating anxiety and promoting emotional regulation in PTSD. Therapies that enhance GABA activity, such as certain medications and mindfulness techniques, aim to repair the brain's braking system, fostering a sense of calm and control amidst the storm of trauma.